All right, guys. So the first part of our lesson is we're just going to take our knowledge of logic. We're going to apply it to normal geometry, so you'll understand our thought process in it. Here's a definition: congruent line segments. Does anybody know what the symbol for congruent it looks like? Danielle? Yeah. Well, congruent, just so you know, is going to be the equal sign with a little squiggle on top. It's the combination of being both similar, that means being the same kind of shape, and equal, the same size. So that's what it means to be congruent. So line segments that have the same measure. How could you write a biconditional out of it? Celine. Line segments are congruent if and only if they have the same measure. So there you go. There's our definition rephrased in a logic statement. So here we go. We're going to study deductive reasoning. We're going to do proofs in geometry, right? You study logic so you can get the hang of like how we go about proving things, starting from a small fact, a small idea, and finally concluding that all the things, all the properties we could ever knew or use from a diagram or a shape or whatever it is that we're given. So here we go. Are we given a shape? No, we're just given a sentence, some words. So one of the best things that you can do is draw a picture. In triangle ABC, let's draw it up. Now, when they give you a triangle ABC, or any shape for that matter, you can't go out of order. Once you start going in a direction, you have to keep it that way. So A, B, and then C. For a triangle, it doesn't matter, but for a parallelogram, rectangle, rhombus, any shape there afterwards, it really does. Angle BAC also, when you're given an angle, it's got to go in that order. B is on the outside, A is in the middle, C is at the end. So BAC is equal to BCA. It tells you that flat off the bat, right? Can you prove this is an isosceles triangle? What do you think? Yes or no? Okay. Well, we're going to do it. We're going to do a proof real quickly. So here's what we're going to do. You ready? Let's go dual screen. Is that too small? Yes? Kinda? No? Okay. We're going to go dual screen. Hopefully it'll work. And we're going to do, we need a statement and we need a reason column. Okay, what do you think we're going to write down first? It happened all the time in logic. Shoot. Of course we're going to write down the given. Let me write that down real quick. So there's our given. There's our given. Let's write down step 2. So now we're going to try and think about this. Congruent, isosceles triangles are triangles that have two congruent angles. It told us in the directions that BAC was equal to BCA. So you could say, well, if it's equal to each other, two angles are equal to each other, what does that make them? Starts with a C. Congruent. So angles that are equal to each other are congruent. Here's my proof. What you first need to know is all the definitions, right? Don't freak out if you don't know them exactly word for word, but you should pretty much know them, really well. Okay. And secondly, you're going to use all of these definitions to present your case. So here it is, the given information. We got a triangle. We got two angles equal to each other. In the next part of the case, I'm going to claim that the two angles are congruent to each other. Not only are they equal measure, but they're going to match perfectly. You know why? Because congruent angles are angles that have the same measure. Yeah? What do you think step 3 is going to be? Do we have enough information to prove the triangle is isosceles? Yeah? Let's do that. Okay. So let's write down, how would you guys describe an isosceles triangle for this last part? What would be your justification? Right? Just think about what it means to be isosceles in your head. Yeah. Sure. Well, since we don't know anything about the sides, it's kind of dangerous to quote something that's not like absolutely given. You know what I mean? Because then somebody else could be like, in here, who always points me out wrong? Dale, you're always pointing out all the, you're great, you're wonderful, man. But you're always pointing out all the things that things could be, you know what I'm saying? So to block out Dale, right, we're only going to quote things that we absolutely have backup evidence for. He's an excellent lawyer, Dale. One day you're going to be very famous, buddy. Yeah? So number three, an isosceles triangle is a triangle, whoa, geez, man, with two congruent angles. Come on. There we go. Okay. There we go, guys. There we go. All right, here we go. So the last part of our little lesson is you can actually prove stuff indirectly. Instead of just trying to attack the answer, right? An indirect proof assumes the conclusion is what? Assumes the conclusion is wrong. What you're trying to prove is wrong, and then tries to prove it right through a contradiction. Let's take a look at an example. This first one. So here we go. Here's an example of something that would come under the category of being an indirect proof, or that might be the primary strategy for trying to prove, the case. Notice that you're trying to prove something is not congruent, not equal. Who here thinks this is kind of dumb because it's so blatantly obvious? Who here can read this? What this says? This given statement. Danielle? Yeah, that's exactly what it's saying. So basically what this thing is trying to tell you is that, look, you're being given two angles. They exist. Do you want to see a picture of them? Yeah? You can't really put any numbers in, but if it helps you try and grasp the idea, here's the deal. Here's J, here's K, here's L. And I'm going to draw it so that it's inherently confusing to you. Here's P, here's Q, and here's R. Now you guys are brilliant and very smart. To some other people, they would say, but they look almost identical, so they must be equal. What do you think? Right. It's not true. Yeah, you can't make those assumptions. Just because it looks like, oh, they're equal, that has nothing to do with it. There's no numbers being thrown in there, nada. Let's throw up our statement and reason proof. Statement, reason. In the interest of time, you'll have to forgive me. Number one is going to be left blank, and you know what I'm going to write down. Just the given. No, you're going to have to. You can't change the format of the table. Number two. Right? Here's what we're going to assume. Oh, I'm sorry. Oh, look at that. I made a big mistake. I'm in such. You know what we're going to do? I am in too much of a rush for my own good. Pause for tomorrow. We'll continue it on. Indirect proofs.